Okay, starting YouTube. Let me share my screen. Desktop. You can see my screen, right?
是的。
OK， 哎，我的那个链接是啥？我有 Google 的链接。Let me kick off the screen first. Wow, it's here. Okay. Full screen. Okay. Let's start. So I'm going to do it in English today. So I'm going through a couple of slides. Just give some background, technical background for how the network works, and then we're going to use some tool to try to sleep the network traffic to understand like how HTTP works, how like DNS works, and also after that we're going to talk about security, a little bit about security, and yeah, just basically we're trying to have some fun here. Okay, so the idea is that first we do it in English. If you have any questions, we do it in English too. Once we run out of the questions in English, then we stop YouTube, and we like a free chat in whatever language, in whatever questions. Okay, so whenever we talk about network, we cannot talk about without this 7-layer model. This so-called 7-layer model basically shows the idea how the network works. It's we can imagine it as like an envelope. It's the same way the network communication is it's very similar to we communicate between people. So it's this is the layer. The top layer basically is each layer is like a one envelope, right? So the topmost layer is application. It will write something and put in envelope and throw into the layer lower, right? So you throw into the presentation layer, then presentation will wrap it in envelope again, you know, and then from top to bottom until like a go physical, right? The physical basically is zero. It's like a electronic signal, right? That's not a really 0, 1 anymore. It's a signal. So this is one part. The sender, right? The receiver will have the same kind of stack, the 7 layers, and it will go reverse, of course. It will basically the physical layer will receiver end will receive the everything in the physical layer first. It will unwrap it and pop to the data link, right? And then pop to the network. Basically unwrap and basically throw the same layer, basically talk to the same layer, right? So the same layer understand the same layer. So, but the idea is that eventually it will go to the application, go to the human. The whole purpose is trying to basically it's a human talk to human or through the application, right? So that's just like when we go to website, right? The browser. So when we trying to type something on the browser, right? So we send to the end, let's say the end have a chat application the same way. So it's go to the browser and send to the browser application will wrap it and go to the TCP/IP layer. So and go to the Facebook layer. So why TCP/IP is so fundamental, and everybody whenever I talk about network, everybody will talk about TCP/IP because this one reason is IP basically tied to the physical machine. That's how we identify the physical machine basically globally, internet, right? Each machine has their own IP address, it's unique, and so that's why IP is always being talked about. Why we talk about TCP is because TCP is the layer that guarantees the secure communication, which means there's no message lost, basically. Here, it's, if you look at this, this TCP layer, if something is wrong on the receiver side, right? Basically, the receiver didn't send the acknowledgement back. The sender will try to resend it. So that's why TCP, this is being managed by the TCP protocol. And the UDP is different. It's the same layer, but it's normally used for broadcast. It doesn't care whether the receiver receives the data. It just keeps sending the data without the receiver will not acknowledge the receiving of the message, and the sender doesn't care either. So that's pretty much the internet protocol, right? So it's the same way. So we human communicate with each other, and based on this, in order for TCP/IP to work, and based on the protocol that for each layer, we have this most popular protocol, basically HTTP is for the website. Whenever we browse the website page, right, applications, we are using HTTP protocol. But in order to use HTTP protocol work, for example, you want to go to Yahoo.com, we have to know the IP of the Yahoo.com. The client your browser has to know. Basically, if you use the DNS service, DNS is pretty much like it's like a database for physical nodes of the world, right? So basically, human doesn't remember the IP, so it only remembers the hostname. So you use a hostname to look up to find the IP address for it. Of course, it's going to be hierarchy. This means there's no centralized database. It's more like distributed database. And SMTP is the protocol also on top of TCP. It's on different port, right? The HTTP also is on port 80. DNS is on port 53. SMTP is on port 25. I listed BGP here is because that's what's given the Facebook troubles. The BGP purpose is pretty much for routing purpose. It's a protocol basically tells once we have the IP, right? We have to know how to reach there. So the reason Facebook went down is that we know the IP address of Facebook.com, but once it went there, the Facebook.com cannot route the communication after it. Basically means within the Facebook's internal servers, it lost the routing, because the routing not just routing internet, but also within the Facebook intranet, right? Because Facebook provides a lot of applications, they have many servers. So basically, we will see there's a command to manage this BGP, to use BGP to manage your routes. Okay. So here is like a many TCP, like a network tools. We can actually look at the traffic. So here we can have some fun based on this. I'm going to show like how the way we use these tools. I'm not sure, like the easiest tool is using Telnet. We can use Telnet to open a TCP connection on port 80. That's the same as we go to browser. You can say here, so this open the connection to yahoo.com. If I open get, it's the same as on the browser, I type HTTP www.yahoo.com. It will return the website, like HTML, right? So this is the simplest way to talk to the remote host. You can just use Telnet, the remote host name, and the port number, right? You can even talk to yahoo.com /3s, I think, right? But I'm not sure if this works. This does not work because it requires ETPS requires a public key, a private key exchange. Of course, I don't have the key here now. So here we can look at. We can also use the most high QA. I mean, to look at network traffic is using this sniffer. One popular sniffer is called Wireshark. So I think anybody can install it, you can run it on your local machine as administrator. Basically, you can see all the traffic here. We can look at it to show. All right, how do I? Okay, I'm gonna have a restart. So we can look at the traffic by doing this. We will say what's happening in order to go to the website. This is some other traffic. So my machine is doing something. Okay. So, but anyway, if we go here, you will say first is trying to, it has TCP connection, right? Trying to which port? Did I look at it wrong? This is the traffic we just doing. It's DNS. First, they trying to figure out DNS. Go to DNS to figure out yahoo.com's IP address. So this is DNS communication. So if we go get, send a request to yahoo.com, we will say more traffic. And here, I'm confused. Anyway, why it's doing this? But that's the idea. But okay. Did I do this? Maybe I should restart. Okay. To monitor this interface. Okay. Now it's trying to look at everything. All the traffic on my TCP. Case sensitive. Okay. See, first it's trying to resolve this it's a TCP application. This what's your port number? And anyway, it's going to this. This is Yahoo IP address, I believe. Right. So if I go type get, okay. So it will. You can say all the traffic, the data here. You say get slash this sent to Yahoo, right? And this okay. So this is a response I got from Yahoo.com, and you can see this HTML response to body, whatever. So yeah, so that's pretty much what's been for this telnet and this wireshark. We can, if you are interested in how DNS works, there's one tool basically you stick. It will give you, they will use DNS protocol and talk to the gateway. So you can see here, the gateway is the server, DNS server is, this is my router pretty much, right? So it will give the answer, say yahoo.com. It's the same name. It's also this. It has a couple IP address for this www.yahoo.com. It's called a record, right? So it is .26, .25, both yahoo.com's IP address. So this is when people talking about the load balancer, right? How DNS could balance the load. This is how DNS basically at some level trying to could balance the load, basically returns multiple IP address. The client can choose, any one of them. So, and also based on different regions, right? So the DNS server knows, because for any network communication, we know the source, the TCP basically is a socket, right? It has a source IP address and destination IP address. And so based on the source IP address, the DNS could know which, who is making the DNS request. So based on, if the user comes from different region, they may return different IP address because they know where you come from based on their route. And so, yeah, so this is how, like another tool we could use to have fun with DNS. Okay, so what else? And another most popular tool is curl. I believe many people use it. And one easiest way to play with it is like, for example, we go to yahoo.com, right? And it's YouTube, not yahoo.com. Okay, so it's let's go to what is it, tool? Anybody want to say something? Where the developer tool? Okay, yeah. Say, okay, go network, right? So I click this IP address, right? So it will, you see this, it will, for one HTTP, for one URL, it goes to so many, making so many requests, because for each page, this page contains many pictures, images, right? So also contains some scripts it's running. So they are like a static file. And based on this static file, it also has some, if JavaScript is running, it could also making some request, that's a request, right? So if we want, okay, here is one way to look at request response, right? So it's HTTP protocol, and one way to simulate this, you can copy this curl, copy as curl. So we can run it using command line. So we will be able to see the traffic here too. So we will see. So okay. Okay, it will save to 8.html. Save. Okay. It's an image. It's not really HTML file. Okay. Anyway, so here basically using command line we can see what's in the request. It's a URL and a header for each header. So many headers, right? Authority and also tells compressed. Basically means the request is going to be compressed. Should be like that. So yeah. So yeah, that's another tool. What's next? Okay, the TCP dump is most usually to troubleshoot networking problem. Like it will same as a Wireshark, but it's not really UI tool. It's not. It's a command line tool. And the next step will show all the routes. It's not just show all the routes, but it can. It will also show a lot of like active TCP connections. Oops. Okay, I don't know how to kill it, but we are interested in the routes. So this is a routing table for your local machine. We can say this, and this is what we run in Facebook too. So if we will look at the routing table, we can say it has a gateway, right? What's gateway? Basically means for this by default, right? All the IP address will try to go to this gateway, and this gateway is bound to this the physical network drive card. Basically, that's the physical card, right? EN0 is a physical card. LO0 is a local. It's a local loop. You can say basically if you have multiple network drive card, basically it will based on the destination IP address. It will pick. If it falls into this is like the subnet, right? Falls into this subnet, it will go to this interface. So this is how what the BGP protocol is doing. Basically, it tells once the traffic reaches to the gateway, it will tell us based on the IP address, the destination IP address, it will use which physical network card and goes to that. So it's like tells the traffic where which route to take, and yeah, basically that's what it is. So that's another command route that can add. This is this. That's the idea basically how to manage this. Only administrator can do this command. So this is basically tells for this subnet destination falls into this IP address range. It will use this route. This gateway. Sorry. This based on the IP address. If you guys knows how IP address is managed, basically. IP address has two kind of two type of IP address. One is public, and the other is private. So private is like a if you say 10.0 something, that's private. If you say 192 or 168, that's private. That's reserved for private. Which means any public domain hostname will not use that. That's behind this public IP, so behind a public gateway. Okay. There's some number of, I think a lot of people when doing system design, they may be interesting because it tells the performance, right? How much traffic, like how slow the network is, right? Basically, every application, if you doing the programming, everybody knows that the bottleneck is always I/O. For the local application, it's I/O to reading or writing to the hard disk, for example, right? And for the network, of course, it's slower than even local network writing. So this is the L1 caching. The L1 caching is the CPU works directly with the register. Right? Anything outside the register will be layered. Everything is layered, right? So it's like L1 cache will serve the register. L2 cache will serve L1 cache, right? So memory will serve the cache. So it's like, so but we go lower that it's further away from CPU, the slower the I/O speed is, right? So you can see that for the network round trip, basically within the same data center, basically means if you have two hosts in the same, let's say Amazon AWS data center, then one connection, like we just saw, right? One TCP IP, like TCP packet back and forth, it's about 0.5 millisecond. So, but it's much lower than, it's slower compared to this memory and of course cache too. So. Okay, so now it's that's the whole purpose for the network. Actually, it's not really useful unless we trying to be able to programming extend the application API over to other servers, right? Remote servers, because this way we can leverage like all different kind of resources, different type of program can work together. So this is the first idea of RPC is just pretty much like an extension of a local library, like DLL, right? So the DLL basically is also share, is trying to, people can share this code program, right? But that's only locally. But in order to be able to call code outside your machine, so the people invented this RPC. That's, but it's based on the TCP/IP protocol. So this is requires a reply. It's simulate the same function call within your one application, one process, but it's a simulation, right? So that's, it has client stop procedure and the server stop procedure, just trying to make the process transparent. Based on that, now everybody knows microservice. Microservice, one key pattern or like fashion for microservices is doing the RESTful API. It's similar to RPC, but RPC is on top of TCP, but REST is on top of HTTP, because HTTP is on top of TCP, right? So REST is simpler to do to program, basically means because it's limited, it's easier, but the only thing is that it will not be flexible as RPC, but it's good enough for everybody to use it, because the bottom line is communication exchange, message, like information exchange. So here we just saw how the browser works, right? So based on the REST API microservice, that means the web application will become much more popular compared to local application, right? If you use computer long time ago, everybody trying to install application on your local system, but right now very few people will install application, right? Because they can just go to Facebook or go to Google instead of install like a local application to do you know, any jobs. So this is basically explains how the browser works. The browser is it's like an engine, right? So it's a host once it's making requests to website, right? And loads the we just saw the here, right? Basically it loads everything, loads JavaScript and everything and HTML, right? HTML basically is trying to render the UI based on the DOM from the HTML, and it will also load the JavaScript. JavaScript is running within the browser. Basically, the browser will parse this JavaScript, inject the code to the browser. Right, the browser will based on the code, the browser will doing things reactively. Basically, by reactively, this means majority application. If not every application, web application is using reactive pattern to do programming. And what reactive programming means, basically means the browser will load the application, the web application as a page, right? Single page application. This HTML is not really typical single application. If you do the let's say Angular, right, or React, do that. Okay. I think this is probably it's a React. Should it be? Yeah, this is a React application. Basically, it will load all the JavaScript, right, into one page, and this JavaScript will render the UI, right, interface, and after that, it will just wait for the event, react to the event. So internally, the browser will have a message pump, right? It will basically pump the message through the message queue, right? And for each message, type of message, based on the code you write from the server side, it downloads to the client side, right? Then based on the JavaScript or it's JavaScript that loads to this along with this page, right? It will respond to the event and drive the application. So that's pretty much how the browser works for single page application. And okay, now we talk about the security. So right now, everybody is using HTTPS, nobody is using HTTP. The reason is obvious. We just saw this, right? So if we use HTTP, we can see the clear text content, right? So if because the internet traffic is using the internet, which is public to everybody, right? So if you happen to be along the route, you can sleep on the this the interface, right? And you can basically watch the communication, right? If it's a clear text, you like using the password, they can say it, right? So that's why they use HTTPS. What's HTTPS basically means it's the same as HTTP, but the only difference is we can say this: before it goes to the internet, right? It will on your local machine, right? When you send the message to let's say to the TCP layer, right? So instead of sending clear text, you encrypt it and then wrap it in the TCP packet. You can say this. So, and I think this diagram is something wrong with this. You don't decrypt until you okay. You don't decrypt. It's the other side. It's the receiver. This I think the website server should stay between this encrypted data and the plain text. So in the middle of this, I would say it will receive the encrypted data and using decrypt key to decrypt the encrypted message. So it's the same. Then it's the same as HTTP protocol. So this here just list some typical encryption algorithm. There are basically two types of encryption. One is asymmetric, the other is symmetric. I don't know anything about the key list actually. The key basically means password. So asymmetric is what the HTTPS is using, right? It's public key, private key. The symmetric is pretty much like a triple dice, a blowfish, and something else, AES. The symmetric key basically means you need a password, shared password. Basically, the sender and the receiver has to share the same key. In order for the encryption to work, the sender has to send the key to the receiver first in order for the receiver to understand the encrypted stuff. I mean, to be able to decrypt the encrypted stuff. The asymmetric key is tricky because it has two keys. One is a public key, the other private key. The reason private key is called private is because you keep to yourself. You share the public key to everybody else. So so this way, basically means people can decrypt your stuff, right? So and that knows it's from you, right? So that's how private key, public key works, and yes. And I'm thinking why HTTPS, when HTTPS is encrypted locally, if everybody has a public key. HTTPS is exchange every time you start a HTTP session, you exchange your public key with the server. So that's how it works, just like a SSH. So, okay, here is GW token. That's how we secure our application, right? How basically OAuth is very popular, and because you don't store the password in your application, you delegate to authorization server. This authorization server basically just like when you log into certain website, it routes you to Facebook or Google, right? So once you log in there, then you get into your the application you want to get into. Basically, that application doesn't really manage your password, doesn't know your password, doesn't say your password either. So so this way, it avoids keeping your password. So make them more vulnerable because the more places your password is stored, the potential, the chances of being broke, right? So being broke. So this GW token basically is used by OAuth. This issued by the authorization server. It's using public key, private key schema. So the GW token itself is clear text, but it has a signature, basically the resource owner can verify you are really you, basically, because you trust the authorization server based on the signature. So, okay. So yeah, pretty much that's all I want to share, and talk too much. Let me see how many people stay online. Any people want to like share any questions, comments? Okay, should I stop YouTube? All right, let me stop YouTube. Where is how do I stop